Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, we are tackling the 6th question from the mid-year examination, which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 9 videos, since the question paper had 9 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are told that an object of mass 85 kg is initially at rest on the ground. It is then pulled vertically upwards at a constant acceleration of 0.75 meters per second squared by means of a light inextensible rope as shown in the diagram below. Ignore air resistance, the mass of the rope, and any rotational effect. Okay, they want us to draw a free body diagram showing all the forces acting on the mass. Okay, this thing is being pulled up by the rope, so there's just this tension on the rope. Number one, tension on the rope, and then we have our gravitational force. Okay, and then secondly, they want us to name the non-conservative force acting on the mass. There's only one non-conservative force over here guys, and that non-conservative force is our tension over here. Né? The tension is our non-conservative force. So since guys we have non-conservative forces, it simply means that mechanical energy is not conserved. Please do not apply the conservation of mechanical energy in this question. Are you together? Mechanical energy will never be conserved in the presence of non-conservative force. Okay, now they want us to calculate the work done by the mass, the work done on the mass by gravitational force when the mass reaches a height of 11 meters. Please note that guys, the work done by gravity is just equal to the change in potential energy of the object. Are you together? It's always equal to the negative change in potential energy. This is just equal to mgh final minus mgh initial. So that's just 85 multiplied by 9,8 multiplied by the height, which is just 11, minus initially this thing was at the ground, so the height above the ground was 0. If the height above the ground is 0, it simply means that the potential energy initially was also equal to 0 joules. So this will just give us negative 85 times 9.8 times 11. This is just negative 9,163 joules. It's negative because gravity is opposing motion, guys. Né? So it's doing negative work. So work done by gravity is just negative 9,163 joules. Now they want us to state the work energy theorem in words. It simply states that the net work done on an object is equal to the object's change in kinetic energy. The net work done on an object is equal to the object's change in kinetic energy. Okay, and then we are being asked to use the work energy theorem to calculate the speed of the mass as use work energy theorem to calculate the speed of the mass when it is at a height of 11 meters above the ground. Work energy theorem, ne? Let's just use the, okay, let's write down there. Work net is equal to the object's change in kinetic energy. By definition, guys, remember that work is just equal to F delta x cos theta. Are you together? So in this case, I'll simply say work net delta x and cos of theta is equal to half mv squared final minus half mv squared initial. Okay, F net, guys, to find F net, there's an equation that says, let me write it over there. F net is basically equal to ma. If I know the mass of the object and its acceleration, I can find F net. The mass is 85, acceleration is 0.75. So that's just 85 multiplied by 0.75. And then the distance traveled is 11 and the cos of 0 degrees. Because the angle between the objects and the direction of motion is just 0, né? And then that's just 1 over 2 multiplied by 85 and Vf squared. Initially, the block was at rest, so the velocity initial was 0. If the velocity is 0, the kinetic energy will be 0 joules as well. So on the left hand side, I simply have 85 multiplied by 0.75 multiplied by 11 and the cos of 0 degrees. I'll simply get 701.25 being equal to 85 times 0.5. 85 times 1 over 2 is just 42.5 multiplied by v squared. Therefore, my velocity will just be the square root of 701.25 all over 42.5. The square root of 701.25 all over 42.5. That's just 4.06 meters per second. So I now know that the speed of the block whenever it reaches a height of 11 meters, it's just 4.06 meters per second. Okay, and then now we are told that a 30 kilowatt motor is used to lift the mass of 85 kilograms at let me erase and read properly. Okay, a 30 kilowatt motor is used to lift the mass of 85 kilograms to this height of 11 meters. Calculate the percentage efficiency of this motor if it is working at maximum power. Calculate the, excuse me, they want us to find the percentage efficiency. Are you together? The maximum power, guys, of the motor is just 30 kilowatts. Are you together? 30 kilowatts, it's just the same as P max. 30 kilowatts is the same as 30,000 watts. Are you together? To change from kilowatts to watts, just multiply by 1,000. So the maximum power, guys, delivered by the motor is 30,000. So they want us to know whether is the motor working with maximum power or not. Are you together? Okay. Let's find the actual power that was required to lift the mass from the ground until it reached 11 meters. Ne? Okay, I know that power is equal to F multiplied by average velocity. Ne? But for me to find the power, I just need to find the force that is applied by the motor. So, but remember that, guys, I know that F net is equal to ma. So there is a force being applied by the motor minus the gravitational force is equal to ma. Remember, there are only two forces acting on this mass. Né? There's this upward force, you can say tension or motor, it's one and the same thing, né, guys, minus the gravitational force. So the force of the motor is just 85 times 9.8, then 85 multiplied by 0.75. So therefore the force is just 85 times 0.75 plus 85 multiplied by 9.8, multiplied by 9.8, ne? 85 times 0.75 plus 85 times 9.8. This will just give us a force of 896.75 newtons. So this is the force that is applied by the motor. I just want to know that is the motor working with its full potential power or not, ne? So the force over there is just 896.75 multiplied by average velocity. You can say V final plus V initial. That's just 4.06 plus 0 all over 2. That's our average velocity, ne? So for us to find the average power produced by the motor is just 896.75 multiplied by I have 4.06 plus 0 divided by 2. What's going on now? Divide by 2. So the actual power, guys, delivered by this motor to lift this 85 kilograms from the ground is just 1,820.4025 watts. So therefore the percentage efficiency is just the actual power divided by the maximum power multiplied by 100. Are you together? So we'll just say 1820.4025 divided by 30,000 multiplied by 100. It's just 1820.4025 divided by 30 hour times 100. So the percentage is just 6.07%. This motor, guys, is just 6.07% efficient. Are you together? It's not 100% efficient, it's 6.07% efficient. That's how, guys, you're supposed to deal with the sixth question over there. 6.07% efficient. So please, guys, do stay tuned and wait for more videos. Thank you very much.